Modern cosmology keeps inventing invisible things to fix problems that won't go away. Things like dark matter, dark energy, missing terms. This episode is about why that keeps happening. Up to this point, we've all felt that something wasn't quite right with how we explain the universe, that explanations keep getting more complicated, that fixes keep multiplying, that we keep adding new entities to rescue old assumptions. But feeling a problem isn't the same as identifying it. That changes now, quiet yet decisively. Every modern cosmological model makes an assumption. An assumption is so basic it's almost invisible. The assumption is that spacetime has a global orientation. That left stays left, that right stays right, and that direction can be carried consistently across the entire universe. We don't usually justify this assumption, we inherit it. But inheritance is not evidence. Locally, the universe behaves beautifully. General relativity works. Conversation laws hold. Physics is precise. The problem only appears when we demand that local rules survive globally. We assume that if something works here, it must work everywhere. And that assumption is the crack. This is a Möbius strip. It's a surface with only one side. No global left, no global right. You can move locally without contradiction. But if you go far enough, orientation flips. This is not a metaphor. This is topology. In Möbius cosmology, spacetime itself is globally non-orientable. Locally, it behaves exactly like general relativity. That's why nothing breaks nearby. That's why experiments still work. But globally, orientation cannot be preserved. And when we force globally orientable bookkeeping into a non-orientable universe, we manufacture ghost. Dark matter, dark energy, missing terms, extra fields. Those aren't discoveries. They're accounting errors. They appear when we mistake structural effects for substance, when geometry speaks, and we answer with particles. Alright, let's pause. What has to be true for all this to work? This episode is not proof. There's no math here, no equations, no deviations. That comes later. This episode is about shape, because once you see shape, the consequences become unavoidable. What you saw here wasn't a conclusion, it was a boundary. On one side is the universe we were taught to expect, and on the other is the universe geometry actually allows. From here on, we stop asking whether the shape is strange, and we start asking what it forces. Welcome back to reality.